Our next step up in degree of difficulty when dealing with similar triangles is, suppose the triangles are not given to be similar. You need to verify that they are in fact similar. So one way that helps is this. There's a theorem from basic geometry that says this: in any triangle, call this ABC. If you connect two sides of a triangle, any two sides, I can connect this side or this side or these sides. If you connect any two sides of a triangle and you connect them with a segment, so let's just pick here. And let's call this D and E. If it is given that these sides are parallel, if those are known to be parallel, then we know these triangles are similar. And once you know they're similar, then we get to use all of our tools for similar triangles. But the first bridge we need to cross is, do we know for sure that they're similar? Well, one way to make sure we cross that bridge is if these are known to be parallel. If these are known to be parallel, then the small triangle ADE is similar to triangle ABC. And the reason we know that is because we know we have parallel lines crossed by a transversal. If we were to make this picture a little bit more elaborate, it would be something like this. Here's D, here's B, parallel lines crossed by a transversal. This angle is here. This angle is here. Those are corresponding angles. And we know for parallel lines crossed by a transversal, corresponding angles must be equal. And by an exactly similar argument, here are two parallel lines crossed by another transversal. So that means this angle corresponds to this angle. They must be equal. And so now we know that in triangle A, D is in dog, E, A, D, E, that's alpha, delta, echo, A, D, E, that this angle corresponds to this angle. Those are equal. And notice angle A is obviously equal to itself. It's the same angle in both triangles. So A is equal to itself. D is equal to B. E is equal to C. So we may say triangle A, D, E, the smaller one, must be similar to the larger triangle, we got some street sweeper going on outside. Triangle A, B, C. Because B is equal to D and C is equal to E. So if you can establish the triangles are similar, then you get to use these similar triangles properties that we've discussed. All right? So let's see if we can work a problem like that. So we're given this picture. Let's call this point O. That's a right angle. So anytime this is given in the picture, we're assuming this is given. So given a right angle, let's call this, it doesn't really matter. Let's call this Q. Let's call this point P. And suppose from a different point, we're also given that as a right angle. So that's given a right angle, that's given as a right angle. Well, look, if these are both right angles, then we know these two lines are parallel because they're both perpendicular to this third line. You see, we have two lines crossed by a transversal, corresponding angles are equal. So these lines must be parallel. All right? Now, for a reason we'll talk about later on, I'm going to call this point Q number 1. I'm going to call this point Q number 2. It turns out that that is particularly convenient for some work we'll be doing later on. And then I'm going to call this P number 1, call this P number 2. So the small triangle and the large triangle Since we know these lines are parallel, then we know the small inner triangle and the large outer triangle are similar. So let's see if we can write that out. Triangle O, Q1, P1 in that sequence is similar to triangle. Now, what sequence do we need to write this? Do you see it? Yes, O needs to correspond to itself. O is equal to itself no matter what. That's the reflexive property. O is equal to itself. And then Q1 is the right angle. Well, Q2 is the right angle. And then O, Q1, P1 would be similar to O, Q2, P2. All right? All right? Now, let's suppose we know this distance is known to be 6. So given that distance is 6, so everything here is given. Well, this is we've deduced. This is given. Let's suppose this distance is 4. All right? And let's suppose we're given, another piece of information here. Let's suppose this distance is 5. 5 goes from here to here. 4 goes from here to here. All right? So we have the triangles are similar. We know the triangles are similar, and suppose we want to find the distance from O to P2. We want to find this big distance, call that x. Well, is this straightforward? Can we say 6 is to 4 as x is to 5? Can we say 6 is to 4 as x is to 5? The answer to that question is no, not if we want to be correct. 6 is to 4 as x is to 5 is not accurate. Because 6 is to 4 is hypotenuse is to short side. In the large triangle, if we use the entire hypotenuse, the entire length of the large triangle, we need to use the entire side of the large triangle, not just this piece of it. So if we know 6 is to 4 as x is to this grand total distance, which we know to be 9, we know this grand total distance is 9. So the correct proportion is 6 is to 4 as x is to 9. 6 is to 4 as x is to 9, and then we back solve for that. And so cross multiply 4x is equal to 6 times 9. So that implies 4x is equal to 54. And so x is 54 fourths. That is more than correct. In all the work that we do, unless there is a specific reason, unless you are explicitly instructed, this is not just for this example, this is not just for this section, this is for the entire course between now and Christmas. Unless you are explicitly instructed to, or unless there's a specific reason to do so, you do not need to simplify your fractions. You do not need to simplify your final result. If you put 54 over 4, this is fine by me. If you want to, that's glorious. If you want to simplify that, that's wonderful. You can write this as 27 over 2, and that's glorious. That's wonderful. If you want to, you can write this as 13.5. If you want to reduce this and you write 27 over 2, that's wonderful. If you write your answer this, you get full credit. If you write your answer this way, you get full credit. If you write your answer this way, you get full credit. If you write your answer this way, you do not get extra points for doing this. You just get the same full credit as anybody else. But watch this. If you put 54 over 4 and you leave it there, that's full credit. Suppose you make a mistake. Suppose you make a mistake when you simplify and you put that. Now you've lost points. You should have just been happy enough with that and left it alone. My rule of thumb is, unless there's a specific reason to simplify. If that happens, I'll let you know. Unless there's a specific reason, let sleeping answers lie. 54/4 is just fine by me. So you do not need to simplify any final result between now and Christmas, unless there's a reason to do so, in which case I will tell you, you'll know about it, and you'll know what to do. All right, so that's our agreement. Let sleeping answers lie. So what I would do if I were you, don't take any chances. Because you know what happens? You get your answer correct, then you start to simplify and you mess it up. Now you're messing with Sasquatch. So just let it alone. Just leave that 54/4, put a box around it, be proud of it, you're happy. Just back away slowly and don't make eye contact. Just let that answer sit there. Okay, so now, that said, that's the process. 6:4 as x is to the entire length. You need to make sure and use the correct establishment of the proportion, otherwise your final result's not going to be correct.